Okay, in this question and video we're going to be looking at factorising quadratic expressions. Now a quadratic expression will come in the form of ax squared plus bx plus c, where a, b and c are merely variables, numbers that can go in front of the values there to give you a quadratic expression. What we're going to have a look at then is, let's have a look at our first one. So we're going to have a look at how we can factorise x squared plus 7x minus 12. When we factorise this is going to give an answer of 2 brackets. In this equation, because it's just got x and nothing in front of the a, we know that the brackets are just going to be an x times an x, because an x times an x will give us the x squared. So from the previous video, when we were looking at multiplying out 2 brackets, remember the grid method? You'd have the x times the x, and that would give you the x squared, and this would be the multiplication of the 2 numbers. So what we're looking for here is we're looking at a set of numbers that when we multiply 2 numbers together, so the product of 2 numbers will give us minus 12, and we'll be looking at where the sum of 2 numbers will give us plus 7. So let's have a look at all the numbers that can give us minus 12. So we could do 1 times 12, 2 times 6, 3 times 4. Oh, sorry, that was a plus 12, so we're looking to give us plus 12 there, I apologise. And we could also have minus 1 times minus 12, minus 2 times minus 6, minus 3 times minus 4. They all give us a product of 12. But which of those 2 pairs give us a sum of 7? Well, 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7, minus 1 times minus 1 and minus 12, minus 13, minus 2, minus 6, minus 8, minus 3, minus 4, minus 7. So we're actually looking at then this pair of numbers here, 3 times 4, 3 plus 4. So what that will mean in terms of our brackets, x, it means one will have a plus 4 in it, a plus 3 in it, and one will have a plus 4 in it. And that is x squared plus 7x plus 12 factorised. So let's have a look at another example. So let's have a look at x squared minus 6x plus 5. So again, let's have a look at those factor pair numbers that will give us a product of 5 and a sum of minus 6 on this occasion. So if we have a think about the numbers that give us a product of 5, it's probably 1 times 5 minus 1 times minus 5. Okay, and the sum of 1 plus 5 is 6, minus 1 plus minus 5 is minus 6. So this is the pair of numbers we're looking for here. So when we factorise this, that will give us x minus 1, x minus 5. And that's how you would factorise that particular quadratic expression. We're going to now have a look at something which is quite similar to that, but not identical. So let's have a look now at how we might do y squared minus p squared. Looks quite different to what we've been having a look at so far, but in reality we can write it as the same. Y squared minus no lots of y minus p squared. So we're looking for 2 numbers that give us a product of minus p squared and a sum of no y's. So we've either got p times minus p, that will give us minus p squared, that's it. And if you do p plus minus p, that will give us 0. So there we have our 2 numbers. So when we factorise this, we'll end up with y plus p, there, y minus p. Let's have a look at a question like that which has got some numbers in it. So let's have a look at p squared minus 81. So similarly, that's the same as p squared, plus no lots of p, we haven't got that middle bit, the bx part, minus 81. So we're looking for 2 numbers that have a product of minus 81 and a sum of 0. So let's have a think about 81. Well, the other 2 numbers I can think of that give me 81 are 9. So to get minus 81, it must be 9 times minus 9. And look, 9 plus minus 9 gives you a 0. So to factorise that, it would be p plus 9 multiplied by p minus 9, and that would factorise it. You're now able to go on and try exercise 8F, page 87 of the book, or have a look at 9F, page 140 on Active Learn. Okay, good luck with that.